Hello everyone, welcome back to the channel. So in the last session, we have started discussing about general characteristics of D block elements. Well, now we are going to continue the continuous part of the chapter. The next general characteristic of those D block elements is the ionization potential. Okay, next property in the next property is the ionization potential, or it is also called ionization energy. Okay, now in ಕರಿಬೋದನ್ನ ionization potential ಅಂತ ಹೇಳ್ತೀವಿ. It is also called ionization energy. Well, what is the name here? Ionization ಅಂತ ಇದೆಯಾ? Ionization. So ion, okay, ionization ಅಂತ ಇದೆ. Okay, ionization. We know that digestion, respiration, so that indicates the process. So ion. So we know that charged particle. Ions are nothing but a charged particle, charged species. So here ionization means is formation of a process, formation of an ion, right? We can consider ionization means so it is a process which involves the formation of an ion. So we know potential. Potential refers to a kind of energy. So potential ಅಂದ್ರೆ ಹೇಳ್ತೀವಿ, yes, it is a form of energy. Now we are looking for ionization potential of D block elements. Well, we consider, say, if I consider this diagram, what it is. So what is this? Yes, we can say, yes, there will be protons at the center and electrons were get distributed, all together constitutes atom. So we can say, if we consider this diagram, it is an atom, right? Yes, it is correct, it is an atom. Now say if we supply energy to an atom, so what will happen to the atom when we supply energy to it? So whenever we supply energy to an atom by some means, so when energy is supplied, what happens? The electrons of an outermost shell, that is electrons, when energy is supplied, say to an atom, if energy is supplied, what happens? Say the energy is taken up by atoms. Which part of the is going to take energy? The electrons of valence shell. Okay, ಯಾರು energy ತಗೋತಾರೆ? The electrons of a valence shell, they take up the energy. Means once they take the energy, where they will go? They goes to excited state. Okay, those electrons goes to excited state, or if energy supplied is sufficient, what happens? They even removed from valence shell. Okay, so well, what we say, whenever energy is supplied to an atom, where that energy will go? That energy is taken by electrons of a valence shell. Okay, well, now what is the possibility? That electron may go to excited state, that is higher energy level, or else that electron may be removed from the valence shell. We have these two possibilities. Well, we consider the second possibility, right? Say when energy is supplied to an atom, it get converted into ion, which means the electron is removed from the valence shell. Okay, means once electrons are removed, what happens? Number of electrons will be, okay, less, and number of protons will be more. Then obviously that ion is going to carry a positive charge, therefore it is named as a cation. Okay, when energy is supplied, if one or more electrons are removed from the valence shell, resultant will be a cation. Well, so now I can say here energy required. So what I'm specifying, energy required for what? Say when energy is supplied, so this energy required to form cation, energy required to form cation is called ionization enthalpy. ಅದಕ್ಕೆ ನಾವೇನು ಕರಿತೀವಿ? Ionization enthalpy ಅಂತ ಕರಿತೀವಿ, or it is also called ionization potential, or even called ionization energy. So what is this? Is the energy required to form a cation. In simply what we are saying, energy required to form cation is called ionization enthalpy or ionization potential, or even called ionization energy. Okay, well, so Now if we consider what happens to the atomic size from left to right. So generally we know from left to right the atomic size goes on decreases, right? In a periodic table atomic size goes on decreases from left to right. Yes, it is also true with respect to D block elements. So in any of the series, if you analyze, yes, atomic size goes on decreases. Generally, atomic size goes on decreases from left to right along a period. Now, ideally, ionization enthalpy should go on increasing in case of D block elements, which means as size decreases, nuclear charge increases. Then we say ionization enthalpy, or I can say this ionization potential should go on increase. Okay, well, if you look at the data, that is ionization enthalpy versus atomic number of different series, okay, first, second and third series, say color combinations, say titanium, vanadium, chromium, manganese, iron, okay, cobalt, nickel, copper. So first series, or you can say 3D series elements, when you look at their, okay, ionization enthalpy value, the first ionization enthalpy value, say from titanium, iridium, chromium, what is the value? What with the help of graph we can say decreases, right? Ionization enthalpy goes on decreases. Then from chromium to manganese increases, manganese to iron again increases. Then from iron to cobalt decreases, cobalt to nickel decreases, and nickel to copper there is a slight increase in the ionization enthalpy. So is the variation. It is with respect to, okay, first transition series, or I can say 3D series. So initially decreases, at the middle just increases, again decreases. Then there is a irregularity in the, okay, ionization enthalpy. Similarly, if you look for second transition series and even the third transition series, yes, it is the same. So initially it decreases, thereafter there will be variation in the ionization enthalpies, the first ionization enthalpy. Well, so it is observed that the first ionization enthalpy increases, but that increase is not very regular. There is no regular increase, rather there is increase and decrease takes place. Well, it is because why we are going to get irregularity in the ionization enthalpy means it is because added electron goes to, okay, when we add electron, that added electron goes to F subshell, due to which shielding is extremely poor towards the valence electrons from the nucleus, since we know that inner orbitals are going to shield the outermost electrons from the nucleus. So whenever electron goes to F subshell, that shielding effect is very very poor. The shielding effect for S subshell is maximum, then P, then D, then F. The electrons, if they are present in S subshell, they are going to show maximum shielding effect, and if they are present in F subshell, they are going to show least, or you can say very very poor shielding effect. So at the last, what happens? Those added electron enters into F subshell, and these F subshells are going to have very poor shielding effect. So extremely poor shielding effect. Therefore, there is a variation in the, okay, ionization enthalpies. Well, now if you consider application of this ionization enthalpy, what is the help? Okay, what are all the parameters can be predicted with the help of ionization enthalpy means, say ionization enthalpy is very helpful in predicting the what, in predicting the thermodynamic stability of metal compounds. So what is the one application? With the help of ionization enthalpy, one can able to predict the thermodynamic stability of the metal compounds. Well, it can be illustrated from a table. Just we consider two elements here, nickel and platinum. Nickel and platinum. So when I look at the first and second ionization enthalpy, the sum of first and second ionization enthalpy, which is expressed in terms of kilojoules per mole. Look at the values. For nickel, the sum of first and second ionization enthalpy, how much it is? 2.49 into 10 raised to 3 kilojoules per mole. And what about platinum? For platinum, it is 2.66 into 10 raised to 3 kilojoules per mole. Okay, when we consider the first and second ionization enthalpy, sum of the first and second ionization enthalpy for nickel. So nickel 2.49 into 10 raised to 3. It's platinum 2.66 into 10 raised to 3. Well, which one is having less? Okay, less sum of the ionization enthalpy values? Nickel. So if we consider first and second, say platinum is going to have higher ionization enthalpy values than nickel, or I can say inter the first and second ionization enthalpy is lesser in case of nickel compared to platinum, right? Well, now it indicates that, okay, the ionization enthalpy first and sum of the first and second is less for nickel, which means first ionization enthalpy means losing first electron, second ionization enthalpy means losing second electron. So after losing two electron, a divalent cation will be formed, that is Ni2 plus, and after losing two electron, platinum is going to form platinum 2 plus. Where the energy required is less, for nickel energy required is less. Therefore, we say Ni2 plus is more stable than platinum 2 plus. So why Ni2 plus is more stable? Means the sum of first and second ionization enthalpy is less. Less energy is needed to remove the valence 2 electrons. Therefore, Ni2 plus will be more stable compared to platinum 2 plus. Well, further, if you go for the next sum of the first four ionization enthalpy values IE1, IE2, IE3, IE4, that is ionization enthalpy first, second, third and fourth ionization enthalpy. Now look at the values. Now look at the values for sum of first four ionization enthalpy values. For nickel, how much it is? 11.29 into 10 raised to 3 kilojoules per mole, and for platinum 9.36 into 10 raised to 3 kilojoules per mole. Now here, if I consider the sum of first four ionization enthalpy values, okay, for nickel 11.29, and for platinum it is 9.36 into 10 raised to 3 kilojoules per mole. Now here platinum is going to have less ionization enthalpy compared to nickel, which means now here what I can say, platinum is having less ionization enthalpy than nickel. So 4 means platinum 4 plus, nickel 4 plus. Well, for platinum 4 plus, less ionization enthalpy required, which means platinum 4 plus is more stable compared to nickel 4 plus. So what we are saying here, say whereas the sum of first four ionization enthalpy is less in case of platinum, therefore we say platinum 4 plus is more stable than Ni 4 plus. Well, so this ionization enthalpy is also helpful in calculating the energy of the system, right? So if you consider first two, the values are different. If I consider first four, again the values are different, which means it is possible to calculate the energy of the system. Then it is also helpful in calculating the heat change. Well, now coming to the MCQs. So it is observed that first ionization enthalpy increases, but the increase is not very regular in D block. Answer: it is because of poor shielding effect, size decreases, atomic weight decreases, all are correct. Yes, it is because of why we are getting irregularity in the, okay, irregularity in the ionization enthalpy. First ionization enthalpy means it is because of poor shielding effect. Okay, it is because of poor shielding effect. So option A is correct. Well, next one. It is observed that the first ionization enthalpy of 5D series is quite high. If we compare the first ionization enthalpy of 3D, 4D, 5D and 6D. So now if we consider 5D, the first ionization enthalpy of 5 series is quite high, justify. So added electron enters n-1d subshell because of actinide contraction, because it's the last series, all are correct. So here added electron enters into n-1d subshell. Well, next one, ionization enthalpy is useful in option A, calculating energy of the system, heat change, predicting thermodynamic stability, all all the above. Yes, what is the answer? All of the above. So ionization enthalpy is helpful in calculating energy of the system, in calculating heat change, in predicting the thermodynamic stability. Therefore, all are correct. So option D is right here. Next one, why is Ni2 plus is found to be more stable than platinum 2 plus? So why Ni2 plus is more stable? Yes, option A, insufficient data. Platinum obeys laws of thermodynamics. The sum of first and second ionization enthalpy is lesser in case of Ni2 plus. None. So yes, why Ni2 plus is more stable? As we said, the first two, sum of the first two ionization enthalpy is less. Therefore, Ni2 plus will be more stable. Similarly, if we consider plus 4 state, platinum 4 plus is more stable. So, as first 4, sum of the first 4 ionization enthalpy is less. Therefore, platinum 4 plus is more stable. Okay. Okay, with this, I'm going to conclude about this session. Again, in the next session, we go for other properties. Okay, thank you. Be safe.